Voyager 2 is dying, but it may be sending back its most important discovery right now. It has no camera taking pictures, no engine pushing it home, no repair crew, and no second chance. More than 12 billion miles from Earth, it is flying through interstellar space with technology built in the 1970s. Yet this aging spacecraft is still telling us things that no modern telescope can. It crossed the edge of the sun's protective bubble, measured the space beyond it, and revealed unexpected discoveries about magnetic fields, plasma, radiation, and even decades-old data from Uranus that scientists had misunderstood. Now its instruments are being shut down one by one, leaving one enormous question: what will Voyager 2 reveal before it falls silent forever? The stakes could not be higher because Voyager 2 is truly irreplaceable. No other spacecraft has ever visited Uranus or Neptune, and no other mission has crossed the heliopause with a functioning plasma instrument like Voyager 2. There is no replacement anywhere close to taking its place. Every signal the spacecraft sends comes from a region of space humanity has barely touched. But its power is fading, and NASA has already begun shutting down working instruments to keep the mission alive. When Voyager 2 finally goes silent, one of humanity's only direct windows into the edge of the solar system will close for decades. The first thing to understand is that Voyager 2 was never expected to survive this long. Launched on August 20, 1977, it began a mission that sounded ambitious at the time but almost modest compared to what it eventually achieved. Its plan was simple: visit Jupiter, visit Saturn, and, if everything went perfectly, continue on to Uranus and Neptune. It would send back images and scientific measurements before eventually fading into history. That was always supposed to be the ending. No one watching the launch imagined this spacecraft would still be communicating with Earth nearly half a century later. Nobody expected Voyager 2 to reach the edge of the sun's influence. Nobody expected it to become one of the only human-made objects ever to enter interstellar space. Yet it kept going, past Jupiter, past Saturn, past Uranus, past Neptune, and beyond the last world ever visited by a spacecraft. It traveled farther and farther until the planets were no longer destinations ahead of it but memories left behind. Today, Voyager 2 is no longer capturing breathtaking images. Its cameras no longer show us new portraits of moons, storms, or planetary rings. There are no fresh close-ups of Neptune's deep blue atmosphere or Uranus's icy world. Instead, the spacecraft sends something much quieter yet far more valuable: numbers, signals, and measurements. Tiny fragments of data travel more than 12 billion miles through darkness before reaching Earth. That is what makes Voyager 2 so extraordinary today. It is no longer showing us planets. It is revealing the very edge of the solar system itself. This is a place that no telescope can study in the same way. A place no astronaut has ever visited, where the sun's influence slowly loses its grip on space. Right now, as Voyager 2 moves deeper into the darkness, it is doing something almost impossible. It is giving humanity direct information from one of the least explored regions of the universe. But there's a problem. Voyager 2 is dying. Its end will not come in a dramatic explosion or brilliant flash of light. Instead, it is fading slowly, watt by watt and instrument by instrument. The spacecraft is powered by radioisotope generators that convert heat from decaying plutonium into electricity. This remarkable power source carried Voyager 2 through the giant planets and all the way into interstellar space. But plutonium naturally decays, its heat gradually decreases, and the available electricity drops every year. As a result, NASA faces heartbreaking decisions about which instruments to turn off. Every remaining instrument is priceless. One measures energetic particles, another studies magnetic fields, and another listens to plasma waves. Each one provides a unique way of sensing the universe. Every time NASA shuts down one of those instruments, Voyager 2 loses part of itself. It loses part of its hearing, part of its memory, and part of its ability to tell us what exists beyond the sun. That is why this mission matters more than ever. Voyager 2 is not simply old. It has become irreplaceable at exactly the moment its life is coming to an end. No other spacecraft has flown past Uranus. No other spacecraft has flown past Neptune. No other mission crossed the heliopause carrying a working plasma instrument like Voyager 2. And no successor is waiting to continue its work. If Voyager 2 finally falls silent, that silence will not last for days or even years. It could last decades, perhaps even longer. That is the central tension of the mission. The farther Voyager 2 travels, the more scientifically valuable it becomes. Yet with every mile it covers, it grows weaker. Every year it makes its discoveries more important, while making the spacecraft less capable of delivering them. Still, Voyager 2 continues to transmit. It is a machine designed before modern personal computers existed, carrying less computing power than the smartphone in your pocket. It travels alone through interstellar space with no repair crew, no fuel for a return journey, and absolutely no possibility of rescue. It has only one mission left: to listen, to measure, and to send back whatever it discovers beyond the edge of the solar system. What Voyager 2 found there was not the quiet emptiness scientists had expected. When it crossed the boundary of a solar system, it did not encounter a simple dividing line. Instead, it discovered a complex, dynamic frontier, a cosmic pressure zone where the outward force of the Sun collides with the vast environment of our galaxy. The measurements gathered during that crossing may ultimately become Voyager 2's greatest scientific discovery, offering humanity its first direct glimpse into the living boundary between our solar system and interstellar space.